what we have here is a set of games that combine art, poetry, and puzzles to teach the principles of sustainability. And these work at any level, from primary to PhD to policy. So you're going to get to be high school students for a bit, and then we're going to just literally go through a series of exercises, a bit like I might actually do this with high school students, or indeed with my own students. So it's about the same I do with them. Then I'm going to talk a little bit about some of the actual pedagogy behind what we're doing. So we'll be first learning a framework of sustainability. That in and of itself is just useful content for you. Okay, so that's what you're doing. For the first bit, you just get to learn a framework of sustainability through playing games. Then we're going to take a little break and look at the pedagogy of how we've been doing it. I'm going to talk a little bit about why we've developed these tools, how we're using them, different ways you can use them to scaffold or differentiate learning. So this is a live dynamic project where we are genuinely working to create a global resource for learning through UNESCO network. So your input will be very valuable. Learning outcomes. At the end of this, you'll be able to identify the key components of an operational definition of sustainability and unsustainability. Just for this moment, you're not high school students. You're actually you're postgraduate students, okay? So this is your learning outcomes as postgraduate students, okay? You'll be able to critically assess environmental issues and their solutions. So really thinking about critical assessment. What's actually going on here? Unpacking some of the key issues. You'll explore how a systems-based approach can promote creative thinking for redesign and sustainability, and you'll gain skills in pedagogical design for multi-generational and multi-level learning. We're going to use, as well as the RoundView hands-on tools, we're going to use Ketso. This is a tool that has been used around the world. I originally invented it in Lesotho, and in Lesotho, the word Ketso means action. So it's a tool for active learning and engagement. What we're doing is creating a toolkit for developing a shared language of sustainability. And what's particularly exciting is that we can leave these in visitor centres, in gallery spaces, and we can reach thousands and thousands of people with this inspiring message of hope about sustainability through the very games themselves. So to make sure that everyone has a chance to speak, what we'll be doing is having a few moments when we're developing our ideas like this, a few moments on your own to write or draw your ideas, okay? And we're going to think, then share, then discuss. So a few brown leaves, and I'd like you to write, so a few moments of quiet, write on the coloured side, one idea per leaf. What does sustainability mean to you? So the next stage, what you're going to do is each person, one person's going to read an idea out, pop it on the felt. Next person, read an idea out, put it on the felt. If the ideas are similar, put them close to each other. And if they're different, put them further apart. Each table is going to just share a brief insight. So what we've got here is a lovely cluster of leaves.
So this was all notions of living within our boundaries and within our means and within the safe and just space. And then this was all about the interconnectedness of things.
All this is about, because I remember one philosopher once said, human being is the measurement of all things. And we recognize this because we need to come up with a notion that our human beings can get along with our nature. And it's not only we save nature, however, the nature is going to save us. So it's going to be humanity, and it should be beneficial for the human beings. And this is about embrace the future generations and the notion of that we need to come things in the very long term. It's for future needs and the universal needs, like fulfill our next generations, their requirements.
So there's some futurity here, and also something about well-being and almost the nature of humanity.
And this part will be more practical and lead to more long-term perspective and more resources like guarantee for continuing life and recycle, continuously updating.
Lovely. So a sort of subjective human focus and a practical. So there's some interesting similarities here. Some insights from afar.
So we all had slightly different versions, but there was definitely connection. So Megan was talking about the importance of biodiversity and being in nature for mental health. And so sustainability is about enriching that biodiversity. And then Panisa was talking about sort of that living in a way that it doesn't cause harm to other people, and meeting your needs, but not denying the needs of others. Naz used a very practical example of, she was talking about how, as a child, she used to do lots of origami. And the idea with that is that you're using the paper in such a way, you never write on it, you never rip it or tear it, so that paper then can then be reused for a second purpose, a third purpose, a fourth project. And it's not used up. It's used, but it's not ruined and thrown away. And there were also elements of community in there that we talked about, like communities not impeding on other communities meeting their needs, both at the same time and also in terms of future generations.
Great. Okay. Thank you. I love the imagery of origami there. That is really powerful. Thank you. I'm planning to take pictures of these, type them up, and hopefully use them in assessing people's learning about sustainability. This fellowship is giving us an opportunity to test this in different sites, work with the UNESCO site managers to really tweak and hone the toolkit to be of the most use to them, and then to develop a resource that can be rolled out globally. We've got quite a lot of problems facing us, okay? Climate change, biodiversity catastrophe, hole in the ozone layer, oceans becoming more acidic, flash flooding, heavy metals and fish. All we've got to do is read the headlines right now. And basically, those are in the headlines, aren't they? More or less, okay? That's the bad news. That is what we're facing. That's why every table was talking about the future. And I think with some element of fear for the future. We want a better future, okay? So that's the bad news. The good news is there's only 3 root causes of all of these problems. And if we can work out the 3 root causes, why couldn't we design things so we don't cause those problems in the first place? So what you're going to do is you're going to play 3 games. Actually, you're going to play 4 games. And whilst you play those games, you're trying to figure out the 3 root causes. If you've got something that looks like a word puzzle on your table, can you do it as a word puzzle? All right. So you've basically got a word puzzle. We'll come around and give you some hints. Everybody's going to get to do all the games. Okay. So have a go. You've got a word puzzle. You've got a word puzzle, and you've got jigsaws. All right. And these show you all 3 root causes and their opposites.
These 2 separate games.
They are 2 games. Yep. Okay. And these 2 give you a hint of this gives you a hint about one of the root causes. This gives you a hint about the other one, and then we're all going to play another game that gives you a hint about the third. So, what's got a relationship with the sunshine? What's that relate to? Lay this out. So what you need to do is you read the whole thing and think about what is this telling cause that you've already got. Okay. This is the root cause of one of those of one of the 3 root causes. So it's got if you consider it as a word puzzle first. Okay. Yeah, that's exactly. So
You want to do the question.
This is in the difference between these 2 things as well.
Yeah, we want
Okay, so you look at this. So once you've done the game, excellent.
the beginning of
Read everything. See, this gives you a hint about one of the root causes. Okay, it's 2 images. You've played a bunch of games. Each has given you a hint, or in this case, a series of hints of the 3 root causes of all environmental problems. Now, this is a very wise saying. If a problem cannot be solved, enlarge it. Okay, so we're looking at all of these issues, all of these problems. It's a bigger system, isn't it? If you want to solve a problem, you need to look at the bigger system. My river is full of pollutants. I can't just solve it by thinking about the river. I've got to think about what's the nature of the problem, what's the source of the problem. Let's think about this system here, okay? This is a system that works. All right? So if sunlight comes in and heat leaves, plants make all the food for the animals that make poo and die and are broken down by the decomposers back into food for the plants. And that's a cycle that goes round and round and round, isn't it? Okay, it works. Now, we are part of that cycle. We have inputs, we have outputs into the system. What is it we're doing that's causing problems? What are the root causes of all of these problems? What is the physical things that we are doing wrong in the way we're meeting our needs? What we're taking, what we're giving back to the natural system? How are we damaging this system? So carbon, there's nothing wrong with carbon, is there? The problem is too much, too fast.
We put in so much chemicals into the ground in a bid to produce more food to feed the growing population.
Okay, you're right there. You've got on the root, one of the root causes there. It's something about the nature of the chemicals that we're putting on the ground. Yeah, isn't it? There's something about the type of material we're putting into the ground and into the water and the sky. One of the key root causes is physically damaging ecosystems. All right, the very ecosystems that we rely on for literally everything. So we physically damage, we cut down, we overharvest, we overfish, we build on, okay? We put tarmac over it, we physically change it, we over-extract the water. And ecosystems do everything for us, right? Every single thing we eat, the air we breathe, everything we make relies on nature. It relies on ecosystems. So if we destroy the very ecosystems we rely on, we're causing a problem. So let's just have the answers to that puzzle about which month, if we saw the whole of the 4.55 billion year story of the Earth is happening over one calendar year, when did these events happen? Okay, so this is the big reveal. So if we think about this whole year, first life only happens in March. All right, the first 2 months, it's just molten rock, bombarded. The oceans don't even cool until February. Then we get life. And then life basically eats most of its own habitat. The first life is bacteria, and it basically eats hydrogen sulfide. Yum, 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 hydrogen sulfide. Oh, it's all gone. Oh, right. What's next? Oh, luckily, in May, algae start to produce oxygen. Photosynthesis, the great invention, the ability to take sunlight and make food. Okay. Now, until this started, almost all the atmosphere was almost all carbon and nitrogen because oxygen burns. It's very reactive. Okay. It isn't until the end of June that enough oxygen builds up from those early algae pumping oxygen into the atmosphere for the sky to go blue. All right. So halfway through the story, we still have a breathable atmosphere, something that we might actually be able to breathe. Halfway through the story. Then, oh, that's pretty cool. Life doesn't just make the atmosphere, it even makes the ability for us to make mountains. There's a huge influx of plankton, a huge die-off of the plankton in the oceans that sinks to the bottom, forms graphite, and allows rocks to move and the mountains to slide and crumple. So life's making our skies, our landscapes. By August, most of the chemical building blocks of life are in place, but we're still at single-cell organisms. Microbes invented almost all of life's chemistry by August. And we're all slimy blobs. There is nothing that we'd even recognize without a microscope until middle of October. Okay, middle of November. The first recognizable animals, something that looked like jellyfish, was the middle of November. All right, and then in fairly quick succession after that, the first plants on land. At the end of November, the first footsteps on land. December is quite an exciting month. So this is where we go to from the billions to the millions of years. Okay, so this is the whole of December. Millions of years. We have coal starting to form. There's so much oxygen, there's giant dragonflies, and there's actually a fossil of a giant dragonfly in the Manchester Museum. 3 foot wide wings. Pretty cool. The first dinosaurs, the first mammals, the first flowers, the mass extinction at the end of the dinosaurs. That's getting close to Christmas. Okay? And then we've got humans start producing tools, and the first known art is in the last 22 minutes to midnight on the last day of the year. So humans don't arrive until the very end of this story. And then we've got the last 1.5 minutes to midnight on the last day of the year, the whole of civilization. Okay, this is after the last ice age, when it's warm enough for agriculture to flourish. There's enough, the ice has retreated enough for there to be enough land for civilizations to flourish. The last 1.5 minutes to midnight. So what we see so far is that life has created the conditions for more life. Life created the conditions for more life and biodiversity, to create soil, to create the rivers, to create inland fresh water, to create the oxygen, to create the ability for humans to finally arrive, for civilization to flourish, and in the last 2 seconds to midnight, the last day of the year, for the whole of the Industrial Revolution. Okay, the last 2 seconds to midnight. So the whole of that Industrial Revolution is the last 2 seconds to midnight. And in that time, we've managed to change the landscape such that we can see the scars from satellite. Life creates the condition for life. Life has actually created and invented all of its own chemistry by August. The second way we can cause harm to the whole ecosystem is by poisoning it with substances that don't belong. We put chemicals on the ground to grow food. What kind of chemicals? There's pesticides, the herbicides. These are substances that never belonged before in nature. Okay? So basically, we poison nature and wildlife with stuff that doesn't belong. The third thing we do is we overwhelm natural cycles with too much too fast. Okay, so this is too many nutrients in the water leading to eutrophication, too much nitrites, the ocean's becoming more acidic. Okay, the oceans are already a bit acidic, that's fine, it's natural, too fast, too much. Acid rain, it's just changing the nature of the flows. We're basically overwhelming natural cycles. Now, we've got some in the middle here, and the reason why these are real problems, is because they're caused by all three. Okay, so any thoughts on what those might be? What are caused by physical damage, poisoning, and overwhelming? They're the wicked problems we're facing, which is what makes them so particularly difficult to solve.
Biodiversity loss.
Excellent, well done. Yes. Anything else?
Climate change.
Climate change. Another big one is lack of fresh water. Okay. Lack of fresh water. Well, if you destroy the ecosystems, you don't get fresh water in. You need trees to get water inland. You don't have fresh water without ecosystems. If we poison it and it's full of plastic or arsenic, or it's undrinkable. If we overwhelm the natural cycles, nutrients, nitrites in water, etc., we're destroying our freshwater reserves. Climate change is caused by, obviously, overwhelm, carbon dioxide, methane, nitrous oxides, but also all the CFCs, chlorofluorocarbons. So we banned CFCs for the hole in the ozone layer and replaced those refrigerants with HCFCs, hydrofluorocarbons, another poison to nature, and a very, very potent greenhouse gas. So sometimes we try and solve a problem and create another problem by not understanding the root causes of the problems. And anytime, for instance, when we were trying to replace fossil fuels, oil, with biofuels, if you end up destroying the rainforests, you end up destroying that carbon sink and the soils beneath them and further cause the problem. So that's kind of the really bad news, because this is what we're doing. But the good news is, if we know the root causes of all environmental problems, and there's only 3, it's not that difficult to get our head around 3, is it? What if we designed our systems to do the opposite? Okay, what if instead of physically damaging, we restored and connect our ecosystems? And the wonderful thing is that nature is extraordinary. Okay, given space, this is the habitat and landscape. The landscape that fueled the Industrial Revolution. This is the coal fields of Wigan, and this is now a national nature reserve. Nature is extraordinary if we give it space to restore itself. Okay, so what if we restore and connect our ecosystems instead of poison with stuff that doesn't belong, plastics and heavy metals and all the synthetic chemicals. Well, first, why don't we not use them, right? That's the first, isn't it? Don't use them. So, for instance, instead of using polystyrene, what if we grew our polystyrene from mushrooms? At the end, it can go onto compost. Major new EU directive banning glitter. Well, banning plastic glitter. What if we use glitter which is biodegradable, made from eucalyptus leaves? Okay, so don't use the poison in the first place. But we're probably going to want in the future mobile phones, solar panels, things that use plastics, things that use heavy metals. What we need to do is make sure that anything that we use that is a poison to nature can be taken apart, reused constantly, that we cycle all materials in the right loop. And then what if instead of overwhelming too much too fast, we were to balance our flows, which basically means living off sunlight. Okay, and if that feels like it might be impossible, I can give you a little bit of hope here. Okay, does anybody have any ideas? How many days of sunshine reaching the Earth does it take to equal the planet's entire reserves of fossil fuels, of oil, coal, gas? Hands up if you think it's 250 days, 500 days, 2, 18. It's 18. 18 days of sunshine is equal in energy to every single drop of oil and piece of coal we have. Now, it cannot be beyond the wit of humans to capture some of that and turn that into our own energy supply. And in fact, recent research suggests that solar panels on half of the world's roofs could meet our entire energy needs. So this is possible, right? That's the piece of hope. If we understand the root causes of all environmental problems, we know their opposites. And then all we need to do is design our systems so that they restore and connect ecosystems, cycle all materials in the right loop, and balance our flows. There's one other thing that we might need to consider. Any thoughts what that is? We also need to consider the impact on people. All right. So what are the other social impacts? What's that? That's that justice. Who is benefiting? Who has enough? So we're part of the system. We also need to consider the impact on our health, well-being, livelihoods, locally and worldwide. Okay. So as long as we do that, we have a sense of direction. We know what it would mean to move towards sustainability. And the RoundView just helps us answer the question, is this decision, is this action more or less likely to move us towards sustainability, giving us a systemic framework and a way to understand that. It gives us a vision. It gives us an understanding of what it is we need to do to move in the right direction. And it's basically all about a sense of direction between physically damaging and restoring, overwhelming and balancing, poisoning and cycling in the right loop, and considering the impact on people. That basically is what the RoundView is, a very simple framework for understanding the impact of our decisions. My real aim from this is to transform the way we think about sustainability and the way we use places to help us think into the future across the globe. I think this is an extraordinary opportunity to work with partners in the UK, develop something that can work here, and think about how we can take this out globally.